Good morning, everyone. I hope you've been enjoying your breakfast. Welcome to the second day of ReEnergize Americas 2012. We've got another very informative, exciting day for you, revolving around energy, water, and economic development. We're going to start this morning with Bob Brumley. I am fairly sure most of you remember Bob from last year when he talked about his project site. Many of you may have read about this project in the newspaper, heard about it on news releases. So without further ado, I'd like to introduce Bob Brumley.
Thank you very much. Appreciate it. I appreciate the opportunity to be here in person. I think last year I was on Skype. And the way I thought I would go through, normally a keynote speaker has about 15 minutes. That gives you a chance to digest your breakfast and get yourselves organized and get on to the working programs that you've got. They've given me a lot of time today. And I think the reason for that is that it gives me an opportunity for the first time in an audience to go through what we've been doing about site in closed-door meetings with private companies, focus groups, the U.S. government, and communities. And so what I have done today is I've taken our focus group material and I have cut it down to what would be a manageable amount of information, but it's still a lot of information. And I'm going to go through it as quickly as I can and then leave it open for Q&A. Finally, I want to start, I should say, with there's a lot of questions about who is Pegasus Global Holdings. Now, what is the company? And I figured I would start with that. The company itself is comprised of basically I have to put this up for the Securities and Exchange Commission. We're not trying to solicit or raise security or sell a security. This is the standard SEC disclaimer. Let me walk around here. The company is a privately owned, privately operated business which has been around since 2002. And the business is like a partnership. You know real estate developers, you know essentially people who develop different kinds of properties, agriculture. Our business is intellectual property development. Now what that means is essentially we operate as a portfolio holding company. We've got a management team, offices in the UK, offices here in the US. What we essentially do is build relationships with the federal labs and the private labs so that we pick technology up after the research and development process has run its course. So federally funded research, we're very interested in use the Bayh-Dole Act, for example, to gain access to federally funded research, or private research where you have a few inventors who've done a lot of interesting work and they've essentially reached a point where they either maxed out their credit cards, lost their interest, or can't manage the business. We like to partner with those guys because they want to see their technology move on, but they've really gone past their ability to really exploit it. So the way we work on this is we both do it in defense as well as in commercial. We create separate structures, operating structures. We have an aerospace company. We have an aerospace group, I should say. We have a tech and innovation group. We have strategic solutions, which does defense. That holds our security clearances. And we have our global IP group, which is Perseus, through our subsidiary called Prometheus. The groups themselves, you'll see below them projects. The projects, for example, in aerospace is Starstruck. Starstruck happens to be a project they're discussing down here in the other part of town at the International Commercial Space Conference that NASA is holding, which is turning White Sands into a commercial launch facility for heavy lift launch vehicles for communication satellites. It would be the first inland launch port in the United States, as opposed to Vandenberg or the Cape on the coasts. We're working on a feasibility study under a CRADA with White Sands and have been for the past year and a half. Starbeam is now, it's an old slide. Starbeam was announced 3 weeks ago in Paris. Starbeam is now called Laser Light Communications. Laser Light Communications is sitting on roughly a significant amount of federally funded research that has been commercialized to us through an IP to deploy the world's first optical wave communication system. What that really means is it's a satellite system that'll have 4.8 terabits of capacity and 200 gigs of up and down link. That's compared to its nearest competitor, which roughly is about 50 megabits of up and down link. So essentially, it's a fiber optic network in space. Pegasus Tech and Innovation, which is SITE. I'll skip that for a second. Our defense business relative to New Mexico is that we have a consortium agreement with New Mexico Tech and Plias as a place for us to take some technology to demonstrate it and also train with it. We have a great relationship with New Mexico Tech, and we feel like Plias is a real asset that they have. Then lastly, Perseus. Prometheus is the vehicle that relates to both the British MOD and Defense Science and Tech Labs, the US labs here, the labs in Singapore, and the labs in Canada. And the way this works, all these work in concert with each other, is that we secure a client requirement, whoever it might be, public or private, government or private sector. We then source and identify the IP. That's Perseus and Prometheus. That's the vehicle we use for that. We then license the IP and secure a franchise. Secure a franchise means that our investment would be on that particular technology, ensuring us a return on the investment if we basically execute. We productize the IP, and then we demonstrate and complete the contract. So, for example, we're the third largest supplier of counter-IED equipment in Iraq and in Afghanistan. Where that fell into was the requirement came from the US government. We found the IP, of all places, in Korea. The Koreans were making electronic warfare systems for the Chinese, and the Chinese were using those systems for basically countermeasures against drug people and people that were essentially dissidents by shutting off all their wireless communications. It's a good system. So consequently, we bought the IP from the Koreans. We brought it to the United States. We reverse engineered it. We filed for patents. We have 4 patents in that area. We sold it to the US government, and the system basically went the route to the right, route to the left, where we formed an SPV, established a new product, and a line of business. That is an 8-year project, and if people Google search us, that's the one that comes up the most because the contracts we have were federal contracts. The idea here on the right, resell the rights of a finished product to IP to a third party, leads us to these 2 channels relative to SITE. Because we do this kind of business, we're always looking for a place to test. And using the counter-ID equipment, for example, you can't test on a golf course. I will tell you that it would be a good place to test because everything is ranged out with plates and how far it is to the green and that sort of thing. But it's against the law. The FCC would frown on that. So you have to find some place that you don't interfere with other people's communication. So where do you test? Because we were not part of the government program at the time, but what was called a COTS, Commercial Off-the-Shelf Entrant, we went and tested in Iceland. We went up to the Naval Air Station at Reykjavik, and it happened to have a GSM network similar to what's operating in Europe, and we tested against that. And the test data was so good, we showed it to the Army and the Marine Corps, and they flew up to Iceland. They saw the test, and then they invited us to go to Yuma to test there. We would find ourselves listed to test at Yuma from 2 o'clock in the morning to 4 in the morning because they did not want to have vendors testing in front of each other. Our test data was classified immediately, and therefore if we didn't have security clearances, it's like taking the final exam and the teacher saying, great job, but I can't tell you your grade. You'll know at graduation, or not. The idea of not being able to control your IP because you have to give up a lot of the essence of it, these were things that we learned over 8 years. And we were in New Mexico when there was some stimulus money here for smart grid. And we came here in 2009, and I met with Tom Bowles, who was a science advisor for Governor Richardson. We were late. The Hitachi and others had gotten the smart grid money, and so we had a cashing note out of the UK that we were selling, and we started talking to Tom about all the frustrations and the limitations and the difficulties of basically doing test and evaluation and also commercialization of technology, which is what is our business. And Tom and we sort of hit on an idea that, what makes a lot of sense would be a place where everybody could come and basically participate, both inventors, investors, government, federally funded researchers, private sector, et cetera, in a neutral place. And in that neutral place, innovate, test, and evaluate, and not have to deal with the bureaucracy of a government-run facility. And that idea was site. The site concept. I come from the school that every one of these words matters to us strategically. A self-sustaining, fully integrated, cross-disciplinary test and evaluation certification facility. What do I mean by that? Self-sustaining. It's got its own power, its own water, it has its own telecommunications inside the fence. Why? Because if you're going to test smart grid, you're going to also be testing indirectly your telecommunications network. You're also going to be testing indirectly their building materials of the homes and the office buildings you're in. You're also going to be testing directly or indirectly in the supply chain for both the storage, supply, prediction, and distribution of electricity. And finally, you're going to be testing appliances. You can't have an activity dependent on outside input like power, water, and telecom, because number one, you can't damage the outside grid you can't risk the grid on the outside of the fence. So by self-sustaining, what you really mean is I'm going to be running a facility that is totally operating on its own, totally self-sustaining, and fully integrated, meaning it's all going to run together. It's all going to work together. And then again, cross-disciplinary, meaning it's multi-sector. There's not going to be like Disney World where you have an energy land and a telecom land and a security land, and they're all just basically sitting off from each other. No, instead, it's cross-disciplinary. Now, where do you find cross-disciplinary challenges outside the pristine nature of a lab? Where we live every day. How many people have been involved in something where you bought a product and it didn't work based on what you thought how it would work because, oh, I'm sorry, you happen to be in a part of town where the cell towers don't reach, or your new washer and dryer, which are supposed to talk to you, don't really talk to you very well because you put them in the basement, or these wireless thermostats where they actually work off of RF can't go through your chimney because they happen to put it on the wrong side of the chimney in the attic. Cross-disciplinary allows you to fail. Cross-disciplinary allows you to test, and test in a way that you can see what not only the success rate is of your product and service, but also the failure rate before you sell it to somebody who lives in Las Cruces or in my hometown. Privately financed, privately operated, privately owned. Why? I get this question all the time. Why, federal government's got innovation money. Federal government's got stimulus money. Why don't you take any money from the federal government? Because of the next bullet. Open to all users, public or private, domestic and international, with special consideration given to qualifying small firms and innovators. We're a small firm. Every time we try to test, I know what line I get in. And it's not the General Dynamics line. It's not the Raytheon line. It's the small business line over here. And that means I know when I test. Might as well sleep in because I'm not testing until 2 or 3 in the morning. In other words, we're given that block of time the other guys don't want. That's number one. Number two is sometimes we get kicked off the range because they just have tested too long and our window is closed. We're always scratching to fight our way onto a federal facility. Number three, they refer to them, and I love them, but they refer to them as the iron majors. The iron majors are the guys who run the programs. And if you look like you're testing something that's going to compete with their program, which means that creates a problem for them, you don't get on the range at all. This, by being privately financed but open to everybody, means that with the rules of ethics and safety and the other requirements that you would have in a facility like this related to public safety and efficacy, anybody can test there. And that is unique. There is not another facility like this in the world that is cross-disciplinary and open to everybody and not government-owned. I'll tell you who likes this the most, open to all users, is the international community. Because their concern is they can't obviously get on American ranges because of ITAR issues and export control issues and security issues. But more importantly, they can't collaborate with anybody to show their own stuff, to enter into this market to compete that possibly could in fact be of interest to either the US government or its client agencies or the private sector. Agnostic to all forms of testing except destructive. Let me define destructive. We are not white sands. We do not intend to blow things up. We are not Plius, for example, that has basically destructive testing. Does that mean that we won't have a transformer if we go up to a load factor of 85% blow? No, it means that's probably what will happen. We'll have storage failures of for electric storage failure. Yeah, that's why we removed the public. We're going to have autonomous vehicles running around an interstate highway system at 70 miles an hour. If they don't make the curve, they go off the road into a field or someone's house. We don't have the public involved in that. That's not our definition of disruptive or destructive. That's our definition of disruptive technology. So it's not our intention to be what would be already exists, and that's what the government does. And that's essentially is blow things up. To be located in New Mexico. The purpose of site, as I mentioned earlier, is to enable and facilitate pre-product testing, full-scale integrated infrastructure to serve as one-of-a-kind proving ground and a valuable asset. These are the two monikers that people generally hear and see about. I talk about. It's a place for you to go to test. Where you start is your business. Where you end up is your business. We're the middle step where you can actually come in and commercialize or productize or demonstrate to those who might be interested in your property, or product, I should say, that they can see it really perform in real-world conditions. You might notice this terrain here. Those of you who are from this area, this project's we've been working on it for about a little over 3 years. It's been public only about a year, about 14 months. And the public nature was necessitated by the agreement we had with the state of New Mexico, as well as the fact we were beginning to reach out to communities for purposes of locating the facility. If you look at this, you might recognize these mountain ranges. That's the Sleeping Lady Mountains, just that way. We have taken out I-10, and we've taken out the airport, but this essentially is the Corralitos Ranch area. This was what we referred to as our red herring model. This is the place that we've been using, graphically to apply how this would look, how it would be structured, how it would operate from a ConOps standpoint. What economic development benefit may occur here to the community, and how far away do we need to build this facility so there wouldn't be any interference or disruptive of other critical industries like airports and that sort of thing. So if you look at it, this facility is 3 by 5 miles. This is what we call the trunk, which is 1 mile square that runs about 8 kilometers out, or roughly around 5-6 miles, out to I-10, and then this facility sits right on I-10. And that's the campus. That's the concept. Now, we have looked to adjust this shape and this size to the area that we might ultimately end up in. For example, in one location, this trunk wouldn't be here. It would really be down here and run out to the highway that way. In another location, there was no trunk at all. It was just an extended part up here, so it was really just one big rectangle. The point we're trying to make is that there are 3 sections to this. One is Site City, which is the site labs. One is the research campus down here, and the other is the backbone, which is the fundamental connectivity of this self-sustaining facility, but its access to the grid. Why site? I mentioned earlier, just anecdotally, about the challenges that we've had. For those of you who are involved in the commercialization of IP or economic development dependent on the federal labs commercializing intellectual property, federally funded research, you'll see that there's a divide. We all in this business just accept the fact that everyone understands what the valley of death is. The valley of death is essentially the divide between federally funded research and successful commercialization. In sum, if you're a federal researcher and you have designated a piece of IP for commercialization, and you're an interested company in that particular output, then the two of you have to meet somewhere and have a transfer of the technology under an IP agreement, under licensing. You've got to have a plan, essentially financing, to be able to build this. For a lot of reasons, this meeting occurs in the Valley of Death, and as the name implies, significant number, if most, ventures fail there. They fail there for a variety of reasons. Regulatory one, working with the labs is another, the difference between a lab's interest in IP and a commercial sector's interest in IP is different. I mean, they're significantly different. And bringing those two together, there are commercialization officers in the lab who have the responsibility to do that, and there are professionals at UNM like Lisa Catilla and others who do that for a career, but there are a finite number of people who do it. Roughly, there's so much in the labs and so little being commercialized that you essentially get the dynamic of what the Valley of Death implies, and that it's littered with good ideas and good intentions and no success. We were characterized once as the guys who have the site would be the oasis in the Valley of Death. We'd be the water supplier, meaning we facilitate a place for the lab people to come under their rules, and where the private sector would come under their rules, and give them a place to interact, give them a place to demonstrate. Lab folks, if they can extend their R&D budgets to T&E, test and evaluation, then we would be a venue for them to test in. If they test, what better place for an innovator to come down and actually see it being tested? Then you get your test data. Then you understand whether you can market and sell it. Best place for an investor to come down and see it actually being tested. So you bring the two together on their own priorities. So the government lab person doesn't have to think like an inventor or an investor. He just thinks like a lab guy. The investor and the inventor doesn't have to think like a lab guy. He basically thinks like what he is. Put them both in together, and that's where they would in fact end up together. We're a magnet for innovation and economic development. For those of you who are in economic development, I know this conference is focused on economic development as well in the energy context. I can give you some examples of economic development which are recent, for example. Yuma Proving Grounds. Yuma, for those of you who have never been to Yuma, was just a sleepy town that grew really quickly in the winter when they had training. The Boston Red Sox used to go there for spring training. It had Marine Corps Air Station Yuma, and that was about it. Not well, in the prison, and that's about it. When the war started, 2002, activity picked up in Yuma. Yuma Proving Grounds is the largest proving grounds in the United States now, and maybe in the world, based on scale. And if you look over the 8 to 10 years that proving ground has developed, you see the things outside the fence that are necessitated because of the activities inside the fence. And what's going on outside the fence are things that sustain the people who are working at the proving ground. So it's not only restaurants and hotels, it's also housing now. It's also office buildings. It's also started as workshops that went to field shops, that went to metal shops, to finally went to what would be businesses that actually SCIC, GD, and others who'd locate down there and essentially locate around what was their principal area of activity. And then you had 2 or 3 different kinds of people. You had users of Yuma Proving Grounds who would fly in, test, and fly out. Their dollar turned over at the hotel and food chains. That's about it. Then you have tenants. That means someone who's actually got an active program they have to support. So they've got to be a tenant there. Those people take office space, and probably stay in extended stay America type hotels. They're down there for 6 to 8 weeks, maybe even longer. Their dollar turns over more in the community. A lot more dollar, a lot more activity, but they're also now paying rent. Then you have essentially residents. That means their program is a 10-year program, like F-35 or something else. They're committed, and they see the dollars, and so they essentially build a presence. That sequence of turning people into, from users to tenants to residents, is the key to economic development. And Yuma is a good example of that. It's a huge now change in that community, and it's only been 10 years. To give you another example, Mojave. Another potential example of that is Spaceport America up the road. As it evolves, it has the potential of drawing people around it. Site will be something like that. We have users. We're going to have people, private sector, government, domestic, international, and lab folks who are going to fly to this place, and they're going to be users. Then on long-term extended programs, they're going to be tenants. That's why that facility that I mentioned earlier, right here, this is for the tenants. This is for the users. This connects not only these two functionalities, but also the world on the data transfer that goes on in here. Then when you go to residents, the residents is the community. So what happens outside the gate, beyond just hotels and restaurants and that sort of thing, It is high-tech, advanced manufacturing jobs. It's jobs related to what's going on in this facility and then the downstream benefits associated with it. We predict 350 new jobs and 3,500 supporting in this facility. The 350 are inside the fence on a 24/7, 365 operating schedule, 3 shifts. The 3,500 are those who maintain the facility above ground, cut the grass, fix things that broke, security, legal, administration, as well as who are working in supporting of what would be the campus. It's a physical place, meaning it's outside a lab. It is actually outside and intended not to be perfect. I mentioned to somebody the other day, they wanted to know, why didn't we build a smart city? I said, because 97% of our cities in this country are dumb. What does that prove? Why don't we build a dumb city and then have you bring your technology and see if you can raise the IQ? If you can raise the IQ of my house, great. If you can raise the IQ of my neighborhood, even better. If you can raise the IQ of my grid, fantastic. At what cost? Because now you get a chance to find out what the real cost is. Not just the projected lab-related cost, but the real cost. And then the trade-off, the law of unintended consequences. You know, this is a full-scale model community. Yes, because I get this question too. Yes, the toilets will flush. Yes, there'll be appliances there. They're going to be built to code. If you don't build it to code, and it's a Hollywood set, then you don't get real test results. It's too easy to say, well, that test result really wasn't real because you didn't have insulation, or you didn't have carpet, or you didn't have appliances, or you didn't have this. Instead, you just did computer simulations and modeling. No, it's going to be a town, just without people. And that town will have 100 homes, downtown, residential areas, streets, et cetera, which I'll get into in more detail. But the point of it is, it'll be a living, breathing city and suburban area and agricultural area so that it is ubiquitous or open to ubiquitous testing. The last part of this is that the technical data will be drawn out of that backbone that I indicated, and it'll be distributed on a confidential proprietary basis on the grid. So for example, if you tested there, you get a dedicated match pair of fiber. That'd be yours. You don't have to come here. You can basically sit, once you've set your test, the site personnel will place your monitors, collect your data, securitize your data, make sure that you get the test results you want, and you can basically monitor it from Los Alamos, DC, or Abu Dhabi. Why New Mexico? Why New Mexico? Well, one of the interesting things about your state, and I'm not a resident of the state, but believe me, folks, I've spent enough time here and enough money here that I almost ought to be paying taxes. I have been up and down I-25 and around about on I-40, and I've done my share of I-10 as well, but I've done the back roads, etc. This state is unique, and to a certain degree, it's unique in a positive and a negative way. In the positive way is that because of all the activity you see on this chart, but particularly because of the federal activities that you see in this chart, your gubernatorial and legislative leadership recognized early on that for them to keep Sandia and Los Alamos and Alamogordo and Wismar and even across the border into Fort Bliss, they need to have the infrastructure that those organizations require. And that means good roads, good schools for the students, as opposed to having to go into base schools. I know, because a little known fact is that my father, my father's a Marine aviator, he was stationed at Sandia. We lived at 1616 Loop at Kirkland Air Force Base, which doesn't exist anymore. There's a slab there. But the point is, I went to base schools. They opened a brand new elementary school, part of the baby boom, and I went off the base, and we moved out into town, and I went to elementary school in, I think it was Espanola. So to a certain degree, I have been a resident of the state for a couple of years. The idea is the infrastructure, since the 50s and the 60s, and to a certain degree even to today, has been driven by the needs of these labs and lab personnel and the federal spend, and because of that, you've got a best-in-class highway system here. Even off the main highways, you've got good secondary roads. You've got an abundance of fiber optic cable. You cover the east-west and the north-south regions from a standpoint of fiber optic cabling and cable pull. You've got good electric transmission. Now, unfortunately, the state is segmented where you've got it in the north part of the state and the southern part of the state, but that's being addressed. So when you're a federal facility, which, by the way, 1/3 of New Mexico's GDP comes from the Department of Energy, $29 billion in 2011. So when you have that kind of spend in this state that drives this kind of infrastructure in the state, then you have to have the complementary university systems like New Mexico State, New Mexico Tech, UNM, that complement not only the needs of their students, but also the needs of the community, which happens to be, as these are clustered, these facilities up here for UNM, these facilities down here for New Mexico State. And if you really, in fairness, look across the border down to Paseo de Norte into Texas and UTEP, you have to really look at this as a single economic, social, political, and technical footprint. So you really get the benefit of, UTEP, Paseo de Norte as a region, including Mexico, culminating up here to New Mexico State, which would include up toward Spaceport. So you see some really interesting growth and development here, and you can see the growth and development up here. So why New Mexico? Good infrastructure, good universities. It's also where the customers are. This is where the federal labs are. Like I said, DOE spends $29 billion here. Los Alamos spends a lot more than that. New Mexico's #1 in federal spend on federally funded research. #1. Bad news, you're 49th in commercialization. How can you be #1 and be 49th? By the way, 50th is Alaska. How can you be 49th? Reason is that notwithstanding all of this, remember, users, tenants, residents. The users fly in and they get the technology and then they leave. There's no reason to stay. But there are some exceptions, and there's been really good work by the previous governor and the current governor to invite companies like Intel and HP and Walmart to locate facilities here. But that real high dollar advanced manufacturing, that next generation IP development type job, you're not getting them. Now, why aren't you getting them? There's a whole variety of reasons why you're not getting them. But at the end of the day is, the good news is if you're 49th, just imagine what happens if you're 25th, which is what my state is, Virginia. Virginia is roughly balanced. It's down on R&D spend, it's below 25, but above that number because of federal spend on defense, meaning shipping and personnel and that sort of thing, command and control. So if you look at this, the other reason why New Mexico, and the big draw for us, was land. You've got 94% of New Mexico is basically public land. 95% of Texas is private land. So when you look at that, public land, tribal, BLM, and what would be state land, then this is a really attractive place in large amounts. It's a big state, as you all know. The idea of being able to build a facility of 25 square miles and build it, that's about 30-some thousand acres, and build it in a place where you are close in cluster to benefit this community and this community down here, but at the same time, build it far enough away so you're not interfering with aviation, the FAA, or the FCC, and you have the privacy necessary to be able to conduct testing that would not interfere with the community. So our view was, and it still remains, that this is in fact the best state for all the reasons I've just given you. We've looked at Texas, we've looked at Arizona, we looked at California, and they all have different benefits and values, but when you rack and stack it, #1 in federally funded research, excellent state-of-the-art communications, excellent institutions, an understanding of federal spend, an attractive Fortune 500 and international companies who come here to do business, communities that are welcoming, and I underscore that because I've met with a lot of communities who really want this, and land. Seems to be a no-brainer. We entered into an agreement with the state of New Mexico in 2011, and that agreement essentially was, we're going to develop, this is not a public-private partnership. This is an MOU where we've asked the state for their support when we need it in a non-monetary way. Let me remember back, privately owned, privately funded, privately financed, not publicly funded. And the only thing we've asked the state is, is to, one, help us promote and facilitate the design of this, which they have done. Anytime that Secretary Borrella's office has called about this, he has this material and others that he can provide them who have interest. Establish a board of advisors to be drawn from the labs, the universities and the private sector. That has been done. It's about 40 people in the state, which met for the first time in December of last year and for the last time in April, and they did their job. They essentially evaluated what we presented to them, listened to what we were doing, and they also helped us in terms of isolating what would be good locations in the state. This private sector board will be replaced ultimately with a local board of advisors. So when we pick the community itself will have its own advisory board that will sit with site so that they know what's going on inside the fence, so they in fact can talk to the community when there are questions about what are they doing out there. Well, then we have a group of community people who can actually answer those questions. Last is no circumvention of Pegasus as the originator or developer. What that means is we don't want, if we're coming here as a private company, I don't want to compete with Los Alamos or with Sandia or with New Mexico State or UNM on another idea where they go to the Hill and get federal money to execute on this while I'm trying to finance this privately. And so essentially this would be our assurance from the state that at least from a standpoint of the state, no third party would be promoted to, that would be a state agency that would be promoting something competitive to this. Range of research capabilities. ITS, these are taken from not just Wired magazine or something like that. Where we have these is we went to the source, went to the federal budget, went to the CBO. The CBO calls these things a lot of different things. At the end of the day, these are the fastest growing sectors for federally funded research in the federal spend. They also happen to be three of the seven happen to be the core spend for commercial companies. So instead of build it and they'll come, no, they're going. They're spending billions on this. They're going in this direction. These are priorities. So consequently, what we have done is built a facility that would in fact identify these as our core sector areas. These are our customer segments: federal agencies, federal labs, FFRDCs. Those of you who smile and know what that means, that is federally funded research and development centers. That's centers of excellence. There are about 550 of them. National Science Foundation handles them. They're distinguished from the agencies that have their own labs, like DOE has Sandia. Universities, research institutions, commercial industries, not-for-profits, resource distributors, and international organizations. And we added film production only because we got a call from Hollywood a year or so ago and saying, if you build it, can we film there? The answer is sure. If we're not testing. The master plan, site is a lab. I'm going to fly through this now. The first part of this is understanding what we're trying to do here. This is now the engineering part of it, so I'll kind of zip along pretty quickly. You guys may all know this, but everybody knows what a section is who lives out here, and you know what a section is composed of, and it's all cut up. Well, a section came out of the Homestead Act back in the 1785 land ordinance. The point of this is we've taken that and decided to use that structure as a grid to zone site. So site is subdivided on the grid. So essentially these grid sections on this footprint will be used as location, if you will, zoning for these potential customers. To do that, we have to have site infrastructure. Think of this as fiber optic, water, power, and telecommunications. The whole grid is going to be gridded. So essentially, look at site, the inside city, as an integrated circuit. So it'll all be built underground. What we're going to build on top of it is a legacy city. So the legacy city on top will be basically the challenges of what a typical city would be, but it'll be plugged, so you can do what we call plug and play. It'll be plugged to this circuitry, and then the circuitry, which is run underground in the network operating center, will be state-of-the-art. State-of-the-art on monitoring, management, data management, transfer, communications, and security. To do that, you have to zone it. So we put up here, we've already got a plan as to where the particular activities would sit relative to the zone, just like you'd zone a community. Where am I going to put a field lab? I'm going to put it over there. Where am I going to put the city lab? I'm going to put it over here. Where am I going to put solar fields? Where am I going to put wind fields? I'm going to put them over there. Where am I going to put the campus? Once you've done that, that means you're building your grid, you're plugging and playing a different function on top of the grid. Then you have an X-ray, if you will, of the city, and that's what it looks like. You've got the city lab in the middle. You have field labs on the outside. You have operations and maintenance facility, which is right there in the middle. That's underground, along with the network operations and data center. And then you have this trunk that comes out here to the Research Institute. And all this gridding allows you to be fully interactive with your customer base, whether they're on the other side of the world or they're just across town or they're in the research facility. Backbone system is fiber optic, water, and cable. The backbone hub, like I mentioned, it's underground. It's hardened so that you can do all sorts of electronic countermeasure, as well as EMP, as well as EW work, as well as just standard commercial RF work upstairs and not interfere with your electronics below ground. Back on the EMP for a minute. Electromagnetic pulse is a hot topic right now. A lot of people want to know how, basically, if you did an EMP test, how you could do it, and then what the impact would be on all the electronics in your community. We can zap the city with an EMP pulse, wipe out essentially all the electronics. That's what happens. But what that results in is it gives you information on how you have to harden your public safety building. Where do you put your communications kit in your public safety building? Everybody has it laying out on their desk, or do you have your emergency public safety equipment inside a hardened room? If you do, you have EMP, it will not affect it, or it shouldn't. How do you test that? This is how you test it. Field labs. Field labs we've gotten interest from both the Saudis as well as from the Singaporeans as well as the Brits on building field labs. What a field lab would be, it'd be just a replication of what site is. Instead of it being Little America, legacy city, it would be a little Riyadh, probably a smart city, because they get no interest, if you will, off proving what they can do on their legacy cities. They want to see what they can do on their smart city investment. So by putting a smart city next to our legacy city, you can test a new Cisco system in the legacy city and get your test results on how you can integrate it into a modern, not a modern, but a legacy American city. But you can also drive it 1 mile over and test it in Little Riyadh on their own technology, on their own infrastructure, at their own standards, operating standards, and see how well it works. You get 2 tests for the value, basically, of 1 location. City Lab, as I mentioned, is in the center. There's a security barrier around it, and then the components. The research campus is roughly about 300,000 square feet. It would be essentially a place that would be open to the public. You could take office space there if you want, but most importantly, it's where those users who are going to come, they'll operate out of here. They won't operate actually inside the fence. This will be their point of operation. They'll have lab space, community space inside it, so they can both do their work and at the same time have the security of knowing that there is a place for them to go store, if you will, or manage what they're doing or store their equipment. The backbone, as I mentioned earlier, is the connection between what would be the city itself and the research campus and the grid, the rest of the world. The backbone is also above ground where we're going to put large solar fields or wind fields. It's a big piece of real estate, so it'll have redundant path for water, fiber, telecom. And so as our output goes out and is distributed, we'll also have input coming in from the grid, and this area would be the footprint for that. Above it would be, as I mentioned before, the other infrastructure that we'd be using. Network Operations Center, below ground, this is called a NOC. The NOC will run everything. Those of you who live in any city in America may not realize, but the power company really doesn't coordinate with the telephone company. And the telephone company really doesn't coordinate much with the water company. They've been built separately. They're distinct from each other. You lose power, they don't call the phone company and say, whoops, I'm sorry. It's just the way our cities have evolved. This facility is going to run the above ground city and all the field labs, but it's going to run all the utilities in one facility. So because we have the luxury of building everything, it'll run it in an integrated way, which basically will test a lot of IBM, for example, smart city system of systems technology, which shows you can really run a city out of a central place. And then the question would be is how do you migrate that learning curve out to existing cities to get the power companies and everyone else to cooperate? Utilities, The plan right now is fossil fuel plant. This is potentiality. That's why the word options up there. Fossil fuel, nuclear power plant, alternative energy, solar, wind, geothermal, bio. It goes in to run our own microgrid, but extra power is sold out to the jurisdiction. And that's important, folks. This is one of the most important things we have here, which I'll get to in a minute. And that's what's on everybody's mind, what's it going to cost, and how you're going to make money doing it. Research campus is going to be supported out off the public grid. We're a buyer of power there. These areas right in here would be, in fact, supported from our own microgrid. And then, of course, the grid also would be a backup power facility. If anybody reacts to nuclear, we're talking about what is now a small modular nuclear reactor, SMR. There's going to be a location. They're going to test them. Ultimately, they're going to want to test them in a community environment. Best place to test them is a place where there's no people. Not because of a risk, but just because of the fact that there's a cultural bias against nuclear power plants. Here's a way you can do a testing and get test data without actually having, the people feel uncomfortable that it is operating there. Water, same story. We have a whole variety of different water strategies. These are driven by where we actually finally locate. We intend to have our own potable water. We're going to do that by desaling existing water and also buying water from the community. We also will sell extra water out to the local jurisdiction. We're a test facility, which means we're going to test next generation water purification techniques. If we do that, what do you do with the water? I mean, after I'm finished with it and it's 30 parts per million or better, do I just pump it back in the ground, into the aquifer? Or do I turn around and pump it into a lake so it looks pretty? Or do I sell it out? We sell it out. That's the plan. The more resource we can produce, that basically provides additional support to the local community and then the community further on is better for us, because then we're showing we're a productive asset, not just a test facility, but we're also producing something and giving back to the community. And it helps the bottom line. Core network, this essentially would be a standard communications network that you have in any city right now, which is things that you really don't think about anymore, like copper, fiber, coax, and wireless. There'll be everything. I've got an anecdote I was mentioning earlier today about a guy who was testing a new Wi-Fi system. He tested it in his apartment. He was testing it off cable, and it was basically a new router. And he was getting huge speeds, and it was like a booster off a DSL line, I think. And he called investors, and said, and he didn't want to take him to his apartment, so he said, I'll meet you down at Starbucks. That's where we all go. And so he goes to Starbucks, he plugs it in, got it ready to go. Doesn't work. Not only doesn't work, it's a dead needle. It just doesn't work. So he tries it again, fiddles around with it, and his guys are saying, when you get it to work, call us, we'll come back. So he goes back to his apartment, works like a champ. Doesn't understand what happened. Until he found out he was testing his system inside a building that he didn't realize was outside the wall, was essentially standard building material, but it covered up stucco and copper wire, which happened to be, in the old days, used for stucco buildings to hold the stucco material. What he walked into was a Faraday cage. What we call in the business is there's a zero wireless capability in there to reach outside of that building onto the street, which is where he wanted to have the ability to be able to use it. He had no idea until he figured that out. So in a sense, your telecommunications network, some of it dates back in our country over 100 years. And the buildings themselves are obstacles because of propagation challenges to be able to work in those environments. You got to know that. Because, for example, fastest growing market for machine-to-machine communications is in your home. Your home is turning into an electronic system. It's dependent, however, not on necessarily fiber to your house, DTH, but the wireless tower. If you happen to be in the part of town that doesn't have enough connectivity or not enough wireless towers to handle all the activity in your area, you're going to have a low capability off of that technology. You're going to get a bad experience, and you're going to think it's the technology, and it's not. It's the infrastructure you're relying on. Field lab. Very quickly, these are just replications of the city lab, except they're done to suit. So if, in fact, the Singaporeans want to build a field lab, we will lease them the land, and they will build the lab. That lab will be built to their specification by either their own contractors or we'll contract it for them, but that'll be their test facility. City Lab, this is the artist rendition of the City Lab. This is on about 450, 500 acres. You have the, and I'll go through it in detail, but the first point about this is a legacy city. What is a legacy city in the United States? It is a city that is, first of all, the downtown areas were built in the 1850s, the streetcar suburbs after that were in the early 1900s, post-World War II expansion, ex-urban sprawl, and urbanization and virtualization. That's interesting as a history lesson, but let me say it another way. Bricks and mortar, some bricks and mortar and steel on building materials, a lot of steel, and then the beginning of composite manufactured material, and then a lot of different types of processed material in your building materials, and then finally more glass and LEED certified buildings. What that really means is when you go into a city, you may see only that, like that guy did in Starbucks, where it's just a Starbucks, but he's really dealing with something that was built sometime right around here and was just upgraded and stuccoed over, or built over. So if you're going to really do a real test, you have to represent all these sectors here. So to do that, you've got to have a build plan that takes into consideration what would be each of these elements, and we have done that. We've allocated, as you see, 10 acres, 5 acres, 10, 35, 85 acres, all of it to be representative in the city. So you then end up with so you have a downtown area, roughly 4 blocks, with tall building, 4 to 6 stories, urban canyons. All that really means is narrow streets in between large buildings to create a propagation challenge. You have industrial area. That's usually the older, in the East Coast, it's the older part of town. It's in the eastern part of town. So in a sense, this is a place that has a lot of old building materials, a lot of wood, a lot of construction, I-beams, things like that. You have streetcar suburbs. These are the ones as mentioned in the graphic that started in the turn of the century, 1,500 square feet or less. These are usually, originally were in that part of town that was on the edge of the expanding downtown, which are now part of your older part of town that spend a lot of time. People spend a lot of time on redevelopment on how we better use these houses and these facilities. You go out to the post-World War II suburbs. Those are the ones that, as the name implies, that you had further expansion. The city grew out because of the road system and allowed you to basically build out larger houses, split levels, 2,500 square feet, maybe as much as 3,000, and townhomes, cluster homes. Micro downtown, that's when you go back to renovate that older part of town. You end up with what is called this micropolitan downtown. That's just little one-block areas that we call now light retail that would be downtown. Very similar you have down here in right near the campus. Then you have the exurbs, which are really the community suburbs that are on the far edges of the community. And then you have we have built a rural ring around this for agriculture. Those are all the common areas that support what would be the technology, but they're made out of the same building materials. So if you look at the streets, you cut through the streets, you're going to go all the way down, and first thing, last thing you're going to hit is dirt, obviously. Then you're going to come up and it'll be paving stone. And then from paving stone, you're going to come up and you're going to basically either have brick, or you'll have tar and chip, or some other composite material. Then you get up to asphalt, and then maybe cement first, and then maybe asphalt to what is finally the final material. You have to do that. So if you're cutting the streets to understand that as you're doing some of this construction work, you're running, into these material challenges. And there's your City Lab. The market opportunity, very quickly now. There's roughly $144 billion has been spent on R&D funding research, of which $64 billion went to non-defense R&D. This slide is really talking about not just where the money is, but where it's spent, but also the public policy that's in place to encourage private sector to actually go after these opportunities. It's better presented in a graphic. Those same customer segments that I mentioned earlier, and the same spend segments, ITS, energy, et cetera, these are the customers. Those spend areas under the federal budget happen to marry with these customers. Consequently, you end up with these systems being funded in the federal budget. So what we've done is we've disassembled the federal budget from the federal labs, for example, or the FFRDCs, and their spend is going to be in these areas. Now, if you look at these areas, ITS, test and simulation, utility, alternate, film, et cetera, smart grid technology, cybersecurity, that happens to be basically the budgets for Los Alamos and for Sandia and for Anil and for Oak Ridge, but they're also the budgets for UNM, New Mexico State, MIT, Stanford, et cetera. They're also the budgets for Microsoft, Google, Yahoo, et cetera. We're all playing in this space. The biggest spender in this space are you people, every one of you, because it's your money. It's taxpayer money that's going to this. The problem is that after you have that spend, which, by the way, globally is $1.3 trillion a year. I'll repeat that. $1.3 trillion a year goes for global R&D, public and private spend. In the United States, it's $427 on 2011 for U.S. research and development. Billion. You know, you were all listening to the debate about where money's being spent. You know, no matter what party you're in, the government is spending almost $500 billion on R&D. And no one talks about that. Now, $500 billion is close to the defense budget, the entire defense budget. But it's parceled out, if you will, among all the departments and agencies, or it's parceled out through grants, or it's parceled out through NSF. NSF has, I think, a $786 million budget. They got a budget increase. The reason is, justifiably, when you're down in your market, you invest in the future, and the future is innovation. We have tracked this spend from the Carter downturns all the way to this downturn. The labs individually may take a little bit of a downturn hit. The labs never go down the way the economy goes down, and they never go up the way the economy goes up. They just muddle along, partly because they're in a 3 to 5 year POM or spend plan, and it muddles along. They may have to lay people off or do some other things that are not hot areas, but overall, they get their money. Their challenge is how they spend it to keep their people there. So then you take the 144, which is U.S. federal R&D, which has actually been identified to the sectors that we're talking about, and then you add the fact that that means they're hiring a lot of private companies and grants and universities with grants, and you get down to what we call the target market, which is $62 billion per year. That's the market we're in. That is the RDT&E market. No one that we can find has ever disassembled the federal budget and to present it this way. Because people just, accept budgets as they are. This money drifts into the Sandia budget and disappears into what's called SG&A, headcount, and operations. They have roughly a certain number that's grant money, but that grant money is immediately allocated to the budget to a business unit, which drops into SG&A, allocation of time and services. So how does our 427 distribute across this distribution? In the larger presentation I've got, it takes this brutally down to, especially for New York and Boston, I take them down to the dollar, okay? I'm not going to do that to you. At the end of the day, our target spend is coming down $11 billion off of the agencies. Federal labs is $8 billion. That's different. These are centers of excellence. These are universities. These are facilities like NASA facilities, et cetera, that are not designated federal labs, but are centers of excellence or FFRDCs. MITRE Corporation, for example. You've got universities, $8 billion. I'm sure someone sits back at New Mexico State or UTEP and goes, where's my $8 billion? I haven't gotten $8 billion. Well, you'd be surprised. You'd be surprised. You look at how robust your grant program might be, and then you look, even though grants may be down, it's because grant writing is also down. It's not that grants aren't available. It's the fact you've got to be aggressive. And I'll give you a footnote. You know the best grant success story in this state? New Mexico Tech. They're fabulous at it. They go after it. They're a machine. If they want to go get something, they may not get billions, but they get $700,000 for desalinization, or they'll get $1 million or so. It's a campus of only 2,500 students. And yet these guys, I bump into Van Romero, who is their #2 guy at New Mexico Tech in DC in Congress all the time. And I'm up there doing other things. Hey, Van. Van is up there all the time. That's how you go after that $8 billion. The $34 billion in commercial, that's a misleading number, because smart grid spend that came from our stimulus went to Sandia. that Sandia money went to, in part, Hitachi. It was reported by Hitachi as a spend on smart grid. Where did it come from? It came from Sandia. Where did that come from? So across these agencies, their money started here at the federal labs. Their money went to UNM and the commercial industries. So there is a risk of double counting. That's why the 144 went down to 62. And then you end up with this target spend on T&E, $1 billion from not-for-profits, $8 billion from the FFRDCs, $8 billion from universities, 11 agencies, and 34 from commercial. What part of that do we need to be successful in terms of a business? We have a customer segment here of power, water, and data center. These are our essential industries that we will start to build. And they basically